All right, so we're doing 5.3, applying all the theorems. We've learned 4. We're going to apply them. So what we did just as an exercise is we defined all of them at our tables. Now let's define them for real. So just in case you forgot, we'll write them out again to make sure that you remember all of our theorems, okay? So the thing that all of them have to be true of, as Pablo pointed out, is that f of x has to be continuous. So it's it's frozen, yeah. There you go. So if f of x is continuous on AB and f of A is less than y is less than f of B, or vice versa, then there exists at least one value of C on AB. I'll slow down after. Such that f of C equals y. And I'll give you a second to copy it down and then we'll talk about it.
People used to be in NHS. I was
I
having
did
some
hear that.
people who graduated from this school this weekend, and they were like, "No, yeah, I was in NHS," and I was like, "There is no way you're in NHS.
Fair enough.
This is ridiculous."
All right, guys. Any questions about IVT? Are we good? We remember it. Excellent. So now we're going to do extreme value theorem. So extreme value theorem. This is if f of x is continuous on AB. Then there must be an absolute max or min, well, absolute. No, let's say n, sorry, not or. And absolute. Well, because think about it, there has to be both on A, B. And then the part that's kind of important is these absolute extrema can be at f of A, f of B, or the relative extrema. So in other words, it can be the endpoints or the relative min-max. Good? Yeah.
The question is off topic. How did they graph function for fancy?
By hand?
Or like,
By hand. You just have to, same as it is on the calculator. You do a table of values and graph it. All right, there's enough noise. We must be ready. Let's do rolls. You must be ready. You're all talking. All right, so Rolle's theorem starts out the same, right? If f of x is continuous on AB, and now we get to our differentiable part. Differentiable on AB, and f of A equals f of B, then there is guaranteed to be a value of C on the interval AB such that, and then I'm going to draw it, such that f prime of C, there's guaranteed to be, yep. There's guaranteed to be a value of C such that f prime of C equals 0. In other words, there will be a critical point.
like
A max or min, horizontal tangent. Yeah, so a critical. And then really we could even add a little caveat here, I guess, because what is this? This is a special case of MVT. That's really what Rolle's theorem is. It's a guy who wanted his name on something. I shouldn't dumb it down to that, but it's probably true.
I think I find Rolle's theorem more useful than extreme value.
That's probably why we gave it its own name.
Because the extreme value theorem is like where else is that
Yeah, I agree.
Maximum.
No, I agree with you. EVT, in my opinion, is like common sense. Like, do you have a brain? Yeah, okay, it makes sense.
Like where else would we have it? If it's not at a maximum, it's not at the endpoint. Where is it? There is none.
Exactly. All right, last one now is mean value theorem, and we're going to start it out the same way.
Oh my god.
I know, right? If f of x is continuous on AB and differentiable on open interval AB, then there is guaranteed to be a value, I can't type, value of C on that interval AB, such that, and then I got to write it, such that f prime of C equals the average. So f of A minus f of B. Oh my goodness. They gave me a new writing tablet and I don't like it. I miss my writing tablet. A minus B. Amazing, right?
But with those
Wouldn't it
definitions-
be f of b minus f of a because it is?
It doesn't matter.
Sure.
All right. So let's actually apply these. That's what this lesson's about. So let's apply them. The rate at which water flows out of a pipe in gallons per hour is given by the differentiable function r of time t. The table below shows the rate as measured every 3 hours for a 24-hour period. Here's our 24 hours. Here's our rate. Estimate the value of r prime of 5, indicating correct units of measure, and explain what this value means about r of t for some reason on another line.
Oh yeah, we have to.
Well, r prime of 5, right, is simply going to be what?
What?
If we're finding the, like, if we're estimating it, what would we do?
What is that sign?
We would use the
Approximately.
closest ones, no?
Yeah, we use the two that are closest to 5. So we're going to use 3 and 6.
Y2 minus Y1.
Exactly. So we're going to get
Fancy.
r of 3 minus r of 6.
What is that sign? Like, es como las dos
No, it's
This means, it means approximate.
Pero es que you do it so
That's because they gave me a new writing tablet and it sucks.
that's not our fault.
I agree with you. It's not your fault. I will try to write nicer.
Is that a 6? Yeah.
So I'm going to get negative 0.4 over negative 3, which is really... Nope, I have no idea. I need my calculator.
It's a little
I mean, it's going to be positive.
Yes, I know because you didn't do it the right way. It's Y2 minus Y1. Please. You should have known it was positive from the
I knew it was positive.
beginning.
0.13 repeating. And what would this be?
That is the average rate of change.
That is R prime of 5.
Which is what units?
Gallons
Hour.
the rate of change of gallons, the
Per-
average rate of change of gallons per hour.
But it would be gallons per hour squared, because this is already gallons per hour.
What?
Why did you square? Yes, because it's like
Ah, but square. The
it's
hours
an
are
accelerated
square.
The hours are squared. Basically, it's the acceleration of the water.
gallons per hour.
How much is the rate of the water changing? That's what it is. Okay? So here, let's write that to kind of help us remember that. So what this means is that the rate at which the water is flowing out of the pipe is increasing at t equals 5, right? So what's kind of helpful about this is the fact that even if the acceleration of the water doesn't make a lot of sense as to something you might want, which there is reasons, it can still help us interpret what's going on. So the fact that it's positive means that the rate at which it is, the water is going is increasing. Okay, because this is effectively the second derivative, and it's positive.
Which one is the second derivative?
Well, the one we just took, because r prime, because r of t is already a rate. So you could think of this as being the derivative, and this as the second derivative.
So shouldn't we write it as r prime?
No, let's
No.
leave it like this. We're doing so fine. Don't confuse
No, we're not going to change that.
us.
All right, so now we're going to use correct units of measure and find the average rate of change from 3 to 18.
What?
So we use 3 and we use 18.
Yeah, we're just basically going to
So
do the
we
same thing,
R
right?
prime of x is equal to, which one is the, but we don't, 18, yes.
So our average is going to be, we'll do it the way that Julieto likes. So R18 minus R of 3
Is 18 minus 3.
over 18 minus 3. R of 18, if we look up, is
0.3 over 15.
so 10.7 minus, is that 10.4?
Yes.
Okay,
And 18
over 15, which is 0.3 over 15, which is, that's 0.02,
What?
isn't it?
Where do you get that?
Your math is failing.
Guys, that's exactly right. Put it in your calculator.
Decimal, sí.
Gallons.
Porque es 0.3 sobre 15.
So that's the same as 3 over
Square.
150 is what I did. Like that's how I did in my head. 3 over,
Don't you have to flip this on?
flip what?
Shouldn't it be equation?
No.
Will we be able to
No,
use
this one's
calculator
increasing.
For this part, like if we have a question like this, will we be able to use a calculator?
No, man.
No. No, you would definitely not get a calculator on a question like this.
So we will just leave the random ugly fraction.
You could just leave a decimal fraction.
Or would you mark points off?
Probably. I'm kidding.
How are we going to
I'm kidding. I'm kidding. All right. Let's do another one. I guess we could say too, like, let's try and identify what these are. This is like MVT-ish. It's not quite because we didn't go and find when it was equal. So we can say it's like MVT-ish.
Okay.
Now we're actually going to use one. Is there some time between 0 and 24 such that the rate the water is changing is 0? Okay, so this is 100% rolls. This is all rolls. All rolls.
Roll.
Rolls. Okay. Why is it rolls? Well, because we want the derivative to be 0. That's rolls theorem. So in order for rolls to work, we need the two endpoints to be the same. What are the only two endpoints that are identical? 0 and 24. Which is kind of a good thing because that's actually what we need here, right? But yeah, so we're going to do like R of 0 equals R of 24, which equals 0. Amazing. And it, oh no, it doesn't equal 0. Sorry, it equals 9.6. The difference between them
Why
is
does it
0.
equal 9.6? Where did we get 9.6?
We pulled it right out of the thing. Right, 9.6 and 9.6.
Ah, yes.
And the difference between them is 0, which is what we need for Rolle's theorem to work. And so basically that's it. That's all it asks us for.
So let's leave that there.
So now we can just say, well, we should say what? So we say like Rolle's,
states.
sure, we'll say Rolle's theorem, sure, guarantees a value such that, and I'll write this one out, I think, R prime of C equals 0. Or if you prefer, like R prime of T, since that's kind of what it asked us for. Amazing, right? Such that R prime of T is equal to 0, or R prime of C. Because when we first defined them, we usually used R prime of C.
Don't you feel like we're being super efficient?
We're being great.
Right.
No, la break es en la página.
All right, let's keep it going. The total order and transportation costs, C of X, measured in dollars of bottles of Pepsi Cola, is approximated by this function, where X is the order size and number of bottles of Pepsi Cola in hundreds. Answer the following questions. Okay. Is there guaranteed a value of R on the interval from 0 to 3 such that the average rate of change of cost is equal to C prime of R. Give a reason for your answer.
Yes, because that is one of the theorems.
Yes.
That one is
Which theorem?
mean value theorem.
Yes, it is MVT.
Yes, because MPT states that if f of x is continuous and differentiable, then there is guaranteed to be a value of c such that f prime of c is equal to the average rate of change.
And how do you know it is continuous and differentiable?
Well, hang on. That's the next part. We're just saying MVT is the one we're trying to use. Now we got to see if we can use it. So from 0 to 3, can I use MVT here from 0 to 3?
No, it's not continuous.
How do you know?
It does. No, from 0 to 3, yes, it has to be continuous.
How do you know?
Except no.
But is it differentiable?
What if it's zero? No.
If we look here, it's going to be undefined, right? At where?
At 0.
But why would it be a negative 3 if we don't have negative 3 on the interval?
Exactly.
You're right, but
We have
0
Yes.
is a problem. I agree that negative 3 is not a problem
Well, why is zero problem? Then we just add it to the.
because you're dividing by 0 and you're not allowed to divide by 0.
Because
So we can say, sorry. So the answer is no.
No.
C of x is undefined at x equals 0. Therefore, MVT cannot guarantee anything. Or is not applicable. They're both fine. Oh, this one sucks to write on. This is so much harder to write on. I hate this tablet. Yes, you should. Yep. Say what? Yeah, you should.
Okay, he's not.
The school, but it's like worse. That's why I bring my own. And they gave me one, so at least I have one. Yep.
Why did this get like 10 euros?
How did I figure out what? Because it tells me that I want the average rate equal to the derivative, which is the instantaneous rate. And that's what MBT is. Yep. How did I find it's undefined? Because the only way to make a rational expression undefined is if the denominator is 0, which happens at 0 or negative 3. And so 0 is on our interval, so done. Doesn't work. All right. Now, is there a value of R on the interval 3 to 6 such that C prime equals 0? Okay, so first of all, which one are we testing? Which one? Which theorem?
We are testing Rolle's theorem.
We're doing rolls, right? Because we want to know, is it equal to 0? Is the derivative equal to 0? So it's that special case of MBT. So the first thing that we're going to need to do then is figure out, like, are those two endpoints 0, right? And so if we look up here, we need to take this equation and plug in 3 and 6. So we need C of 3. We need it to be equal to C of 6 in order to use Rolle's theorem. Okay? And if we plug those both in, which we should just do in our calculators.
1/3 plus 1/2 is what?
It's 5/6.
I think it's, yeah, I was going to say, it's more than that. So 5/6 of 10,000, so I don't know, 8,000 something. I don't know.
So Desmos is.
All right, fine.
I love Desmos.
All right, 10,000 times.
Are we sure it's 5/6?
Regardless, you're going to be.
Yep. All right, so these things are both equal to 8,333.3, repeating basically.
But why do we know that they are the same if we haven't plugged in 6?
No, I plugged in both. Because if we plug in 6 here, we get 1/6 plus 6 over 9, which is 2/3, right? 1/6 plus 2/3 means this needs to change to 6, so we get 4/6, and once again we get 5/6. Basically, the stuff in the brackets for both of these is equal to 5/6 for both.
8.3
Such a value of R exists.
All right, so we can use rolls. Whoops. So we can use rolls. Now we need to actually use it. We got to use it. So that means that I need the derivative of this thing first. So c prime of x. Actually, let's start with just c of x. So I don't have to keep looking up and down. So c of x was 10,000
times 1 over x plus x over x.
all right, which is actually a bit of a pain. Is it? No, it's not. I know. Actually, it is a bit of a pain because we're going to have to take the derivative of both of these anyway. So let's rewrite it. Let's rewrite this with a common denominator. So it'll be 10,000 times x plus 3 plus x squared, both over x times x plus 3. Why am I using that? Because 1 over x needs to be multiplied, basically, here. I have to multiply this by x plus 3 over x plus 3. And I need to multiply this one by x over x, because then I'll have a common denominator of x times x plus 3. So that's how I did it. Which means that c of x is really going to be 10,000 times x squared plus x plus 3 over, might as well simplify that, I guess, to x squared plus 3x. Right, and I'm just doing that because now I can take the derivative more easily. X squared plus x plus 3, right? I'm just literally putting these together, guys. Don't overthink it. We're literally just rewriting this as a single fraction. That's all. Now I can take the derivative. Exactly. So 10,000 out in front of everything. And then low. D high, so plus 2x plus 1. Okay, but you did it right. Low. Okay, I see. Minus. Minus the derivative of the top function, or the normal top function, high d low, so x squared plus x plus 3, multiplied by d low plus 3, good, all over x squared plus 3x squared. Gross. All right, I'm not going to lie to you guys. I have good news. This is a graphing question. You should definitely graph that. Okay? Yeah, you're going to have to graph this one. So let's go ahead and do that. All right, so it's going to be 10,000 times.
So x squared plus 3x times.
Wasn't it just plus 3?
No. No, because it's low behind. No, look at it. I am right.
Yeah.
I am so smart. You know, much less we desire.
D.
2x plus 1 minus.
Guys, you're all talking way too much. You should probably make sure you know how to do this. Maybe even do it yourself, not just be talking.
X squared plus x plus 3 times 2x plus 3.
Wait, what?
X squared plus x plus 3.
Okay, plus 3 times.
2x plus 3.
Okay.
All over. X squared plus 3x all squared.
Gross.
Yes, 3x. You're missing an x.
All right, so our two answers are going to be negative 1.098 Does that make sense?
So it's
Yes.
x
Well, even if
equals
it doesn't make sense in the sense that what is our interval? From 3 to 6. So it's got to be just this answer here. 4.098.
so it's c prime.
I guess I should write them both though.
No, why?
Somebody write those down for me and then we'll show that one of them
So
doesn't make
it is
sense.
c prime of 4
But write those both down for me.
0.
Okay, so here we got that x was equal to negative 1.098 or 4.098. Yeah.
C of 4.098.
And then we would say outside domain or outside interval. And so our answer is just going to be this, when x equals that. All right, we got one more till the break. Okay, from 3 to 9, what is the greatest cost for order in transportation?
Can't we just use the same color?
Greatest cost.
Kind of.
Max.
So what are we using? We're using
We're using EBT, right?
EVT. We want to find the absolute greatest cost. So what are we going to have to check? We got to check C of 3, which we already did. That was that 8,333.3 repeating. We're going to have to check the critical point, which is 0.4098, which we haven't done yet, so we're going to have to put that in. And then we're going to have to do C of 9, which we haven't done yet either. All right, so let's have the boys put in this one, the 4.098, and the girls do 9. What? Girls are doing 9. Into the original equation, yep. All right, we should have them. Based on the amount of talking.
No, we are struggling because Alina's vertical and that's the
Boys in the back table, I changed your mind. Your table's giving us both answers because you're clearly not paying attention. Is she a boy? Yeah, but you're boys. You're supposed to be finding a different number. For twos, which one did you get? No, you weren't. You guys were all talking. You don't have to ask. You know that. All right, you guys. Come on. I put them both into my calculator faster than you guys put one in. Anyways, let's at least learn how to interpret them. So, which one of these is going to be the one that we're looking for? Yes, because this is our ab max. And it's 9, what was the measurement in again? 9, measured dollars, X is in the order size in hundreds. So it should be, if it's 9, that means it's going to be 900 bottles. All right, so we got that it was 9, which meant 900 bottles, because I don't think that was on the last video when it cut off. Because the question told us that it's measured in hundreds of bottles. So 9 would be 900. Hey boys, you're all too loud. Emilio. Thanks, buddy.
Stop there.
No. Car company introduces a new car for which the number of cars sold S is modeled by the function S of t equals 300 blah blah blah, where t is the time in months.
What's that?
No saying.
No say.
Find the value of S prime of 2.5. Using correct units, explain what this value represents in context of the problem. Okay. So in order to find S prime of 2.5, not yet. It might be later. But for now, we're just finding what is the derivative at 2.5. So after 2.5 months.
So 5 over.
So to start with, let's do the same kind of thing we did last time, where we rewrite this equation with a common denominator, right? So we're going to get 300 times 5t plus 10 over t plus 2 minus 9 over t plus 2, right? All I did is get a common denominator by multiplying 5 by t plus 2 over t plus 2, because now I can put all that together.
So it's 5t plus 19.
Not quite.
No. Plus 1.
Plus 1, exactly, over t plus 2. Now you could either leave it like that or distribute the 300 in. I don't care. I'm going to leave the 300 out. I think it's a little bit easier. Okay, so now what we're going to do is we're going to find S prime of t, which means that we're going to have 300, and we need to do a nice big quotient rule. So low, d high, which is just times 5, minus high, d low, which is 1, all over t plus 2 squared.
Below is nothing.
D low is just 1.
So it's not.
Kind of. All right, now we should probably simplify that because I can see very easily that a bunch of that stuff's going to cancel out. So we're going to get 300. On the top here, we're going to get 5t plus 10 minus 5t minus 1. Whoops. Over t plus 2 squared, which is the same as 300. 5t cancels with 5t, so I'm going to get 9 over t plus 2 squared.
I hate writing close to because it's just like why are there so many close signs?
Fair enough. All right, so then we're supposed to find the derivative at 2.5. So let's now go ahead and do S prime of 2.5, which just means that we're going to plug 2.5 in for t. And so that's going to be
What's 4.5 squared?
300 times 9 divided by 4.5 squared, which gives us 133.3. Is this just the number of cars? Yes, cars per month. Okay. So in other words, we are increasing the number of cars we sell each month by 133.3.
But is it with the hat or
That is MPT.
No. What?
Shouldn't you be rounding down? Because I mean, you can't tell like 0.3 of a car.
Yeah, probably. I mean, we probably should, but at the same time, like the College Board is usually going to get you to do 3 decimals. But yes, realistically, we could think of it as 133 cars per month that we're increasing it by. All right, so then find the average rate of change of cars sold over the first 12 months. Indicate the correct unit of measure. Sorry. I guess I should actually write out what I said, which was that this means that the number of cars sold per month is increasing by 133 cars per month. So it's not that they literally sold 133 cars, it's that they're selling 133 cars more each month. And then if we want to find the average, that means that we're going to go back to like almost like pre-calc. Yeah, well, 0, but yes. So S of 12 minus S of 0 over 12 minus 0. S of 12. So if we plug that in, 5 times 12 is 60, so 61 divided by 4. So we get 1,307 minus 150 over 12, which is going to be 96.429, or realistically, what makes more sense is 96 cars a month. Now, what does it mean in context of the problem again? This means the average number of cars sold per month for the first year was 96 cars per month. Is it possible that a value of c between 0 and 12 exists such that that derivative is equal to the average rate of change?
From 0 to 12.
So in this case, MBT guarantees this. And then, of course, that means that now we need to actually find it, right? So, S prime of C is going to be equal to 96.43. And we know that S prime of C is also equal to 2,700 over T plus 2. So what it did is we know it's equal to this, the average here. And we want it to be equal to this, and 300 times 9 is 2,700. So I just simplified this one. I took the 300 times 9 over T plus 2 squared. Okay? And then basically I'm going to make those two things equal. So I'm going to get that 96.43 is equal to 27 over T plus 2 squared. Now normally we make it equal to the average formula, but we already found the average formula, so I don't need to do it again, right? We know that this is our average here. This part is the average, and this part here is the instantaneous. And so we're just making those two things equal. So I'm going to multiply both sides by T plus 2 squared. So I'm going to get T plus 2 squared times 96.43 equals 27. So then I'm going to divide by that 96. And I will get T plus 2 squared equals, I might leave it like that for now. Yep. Yep. Thank you. It is definitely 2,700. I don't know why I dropped the zeros. Thank you. Yes. And then I'm going to square root that. Right? Because then I get T plus 2 equals the square root of 2,700 over 96.43. And then my last step is to subtract that 2. And so I will get that T is equal to the square root of 2,700 over 96.43 minus 2. And then we just got to put that in our calculator to figure out what it is. So square root of, so that's going to be 5.29. So basically we're going to get positive or negative 5.29 minus 2. So we're going to get that T is equal to 3.29 or negative 7.29. Does negative 7.29 make any sense? No, exactly. That makes no sense, right?
If we that subtle simplify it all the way, what happens?
If what? Sorry.
That anything subtle simplify it all the way, what happens?
They sometimes dock marks. It depends. So it's going to be 3.29 months. And we're good. Amazing.